This is a quick video to answer a question that several people have about what's the deal with subtracting 12.5 from education. So if you don't subtract 12.5 from education, as you see in this first graph, the estimated regression line, represented here by this black line, shows what the estimated or predicted value of log wage is at each value of education. Notice that the intercept is when it occurs when education is equal to 0. Now, these blue lines represent standard errors. And I haven't talked about this very much, but one of the things to note is that the precision of the prediction on the on the predicted regression line is much more precise, much more close, smaller standard errors around it at the mean of the value for the x variable. And so since 0 is so far away from the mean and it's not even a realistic number, the standard errors for that estimated coefficient on the intercept are quite wide. And so you get a very precise, statistically insignificant estimate. But if you, over here on this graph, if you subtract 12.5 from education, then actually the intercept, where the education minus 12.50 is 0, 12.5 is 0, that's actually when education is at its mean, 12.5. And so the intercept then is the intercept when this variable equals 0. Education minus 12.5 equals 0. Well, that occurs when education is equal to 12.5, the mean. And so the standard error around the intercept is much narrower. And so it's just by shifting the regression line to the left towards the mean, so the intercept occurs at the mean, you get a much more precise estimate. Nothing else changes but the precision of the estimate around the intercept. So you might get a slight change in the number of the intercept, and you'll get more precise estimate from it. That's what this is about. And again, it's example 7.10 in the text that discusses this. So you might want to review that and then maybe come back and look at this video again if that helps.